going to fill out our foldable. On the back of it, I'm going to write down the EQ that we're going to have for this next lesson. Our essential question is going to be, how can you use angle relationships to solve problems? And an angle relationship has to be with a pair of angles, just like if you think about relationships you have with, for example, a sibling relationship. It takes two. It takes a brother and a sister, or a sister and a sister, or a brother and a brother. So when we're talking about angle relationships, we're talking about a relationship between two angles. Let's look at congruent angles first. If you open up congruent angles, angles that have the blank measure, same measure. Congruent means the same. And we've got angle 1 right here. This is read as the measure of angle 1. So that M represents the word measure. And this symbol right here is an angle symbol. The measure of angle 1, if it's 100 degrees, the measure of angle 3 is also going to be 100 degrees. You can tell that they are the same measure. They're the same size. If the measure of angle 2 right here is 80 degrees, the measure of angle 4 is also 80 degrees. And if you add up angle 1 plus angle 2, you're going to get 180 degrees. And you can see that that is a straight angle. If you think about it in forming a circle, it's half of a circle. You may know that a whole circle is 360 degrees, and half of that would be 180 degrees. Angle 2 plus angle 3 also equals 180 degrees. And then angle 3 and angle 4, that's 100 degrees plus 80 degrees, also equals 180 degrees. Angle 4 with angle 1 also equals 180 degrees. So any of the two angles next to each other add up to equal 180 degrees. And if you add up the 80 plus the 100 plus the 80 plus the 100, you get 360 degrees, which is a circle. Now the next part of our foldable we're going to look at is the vertical angles part of the foldable. And vertical angles are going to be opposite angles. They're going to be opposite across from each other. And they are formed by two intersecting lines. Intersecting means they cross through each other. Now, when we're thinking about vertical angles, they are going to be a type of congruent angle. They are the same angle measurement. So you can see angle 1 and angle 3 are across from each other. They're opposite of each other. So they're an example of vertical angles. Also, angle 2 and angle 4 are opposite angles across from each other, formed by these intersecting lines, and they are also vertical angles. And they are congruent. So if I knew that angle 1 right here was 110 degrees, then I would know that angle 3 is also 110 degrees. If I knew that angle 2 was 70 degrees, I would also know that angle 4 is 70 degrees because vertical angles are congruent. They're the same size as each other. And then the last part on this side is adjacent angles. Adjacent angles are pairs, because remember it takes two to have a relationship, and in this case an angle relationship. Pairs of angles that share a vertex and one side but do not overlap. I think of them as next door neighbors. They're right next to each other. Angle 1 and angle 2, they are a pair of angles. They share a vertex. The vertex is this point right here. And they also share one side. They're sharing this ray right here. Those are an example of adjacent angles. And then angle 2 with angle 3, they are next to each other. They are adjacent angles. Angle 3 with angle 4 are adjacent angles, and angle 4 and angle 1 are adjacent angles. They are not necessarily congruent unless you're thinking about both of them being 90 degrees, both of them being 80 degrees. So they're not necessarily going to be congruent. You can tell angle 1 is obtuse, it's larger than 90 degrees. Angle 2 is acute, it's less than 90 degrees. So there's not a rule for these to be congruent or not congruent. All you need to know for adjacent is that they're right next to each other. Now let's talk about complementary angles. Complementary angles, again, it's a pair of angles. So two angles whose measures have a sum of 90 degrees. The way I remember that it's 90 degrees is complementary starts with a C. So you can make a C and you can turn that into a 9. So it's 90 degrees. Right here, we've got an entire angle, a right angle, and we know it's a right angle because of the 90 degree symbol right here. This entire angle is called angle ABD. But it's made up of two smaller angles. The first one is angle ABC, and we know that it's 38 degrees. We also know that this entire thing is 90 degrees. So if I wanted to find the measure of angle CBD, all I would have to do is 90 minus 38, and that gives me 52 degrees. And you can check it by adding up 52 and 38, and you'll get 90 degrees. And then over here, if I know that this smaller angle is 40 degrees, I could do 90 minus 40, and I get that this one's 50 degrees, and we would write that out as the measure of angle X is 50 degrees. And then supplementary angles. They are two angles whose measures have a sum of 180 degrees. We were talking about 180 degrees earlier when we were talking about those congruent angles in those examples. Right here, if I made an S for supplementary, I can turn that into an 8, and that reminds me that it's 180 as opposed to complementary being 90. This entire straight angle, this entire 180 degree angle is angle QRT. You put the number or the letter that would be considered the vertex, the middle part, in the middle of your angle name. And then I know that angle QRS is 59 degrees. What would be the measure of angle SRT? All I have to do is 180 minus 59, and that gives me 121 degrees. And I can check these by adding those back up. The measure of angle SRT is 121 degrees. When I add those back up, I get 180. Right here, the measure of angle X, all I have to do is 180 minus 145, and that's going to give me 35 degrees. And those add up to equal 180 degrees. Alright, you should have your foldable for angle relationships filled out now.